So we discussed about the Lewis structure. Nitrogen has a electronegativity of around 3. Hydrogen has a electronegativity of 2.2. So the difference is 0.8. So that falls under the polar category, correct?
Yeah.
And since nitrogen is more electronegative, right? We will
Hmm.
put a delta negative charge on nitrogen,
Yeah.
okay? And delta positive charge on the hydrogens,
Right.
correct? So
Yes.
now if we put the now what we do, we put the dipole moments. How do we draw the dipole moments? We start from the positive terminal and we extend it to the negative terminal.
Right.
We start from positive and extend it to negative.
Negative.
We start from the positive,
Go towards negative.
negative, correct? Now, if you notice in this structure, it appears that this and this
They
are
cancel out.
canceling out each other. But the one over here, right,
Hmm.
is is remaining, correct?
Right.
So because that is remaining, there is a resultant uh, dipole moment, correct?
Okay. Yeah.
So this resultant dipole moment is applicable to the entire molecule,
Okay.
okay? And because there is the resultant that exists, this molecule becomes polar, covalent,
Okay.
okay?
Okay. Got it.
Am I clear with that?
Yes, sir.
So this is a concept of molecular dipole.
Okay.
So in a molecular dipole, you consider the bond dipoles. What are bond dipoles? This is a bond dipole. This is a bond dipole. And this is
Hmm.
a bond dipole. And what is a molecular dipole? The
The
resultant
total
of
dipole.
all the bond
Dipole.
dipoles will give us the molecular dipole.
Okay. Got it.
Correct? And if
Yeah.
the resultant is getting cancelled, then the molecule is nonpolar.
Okay.
Okay, is this understood?
Yes, sir.
Okay, if like in grade 12 you are going to learn uh, about valence shell electron pair repulsion theory,
Yeah, Vesper.
correct?
We're doing that.
Yeah, you are doing it now? Okay, that's good then.
Yes, sir.
Okay, then I'll introduce that too. So once you draw this structure, right?
Hmm.
Okay, then since it is already there for you, I can cover it for you. Okay, so once you draw the Lewis structure, right? Uh, what happens is you have, oh, sorry, erased the structure. So you
Yeah.
have the Lewis structure, which is this, right?
Mhm.
You will make it this way, correct?
Yes, sir.
Based on, and then if your teacher has already explained Vesper, then she might have told you that these are the two lone pairs,
Yes, sir.
correct? These are lone pairs, and these are called as bond pairs,
Yeah.
correct? So we have three bond pairs and one lone pair. Now, how I tell my student to remember it, I'll tell you. Lone pairs, I ask them to assume, are closer to the atom.
Hmm.
Okay? And imagine that the bond pairs are slightly away.
Okay. Got
Okay?
it.
Will you be able to imagine that? Whenever you imagine lone pair, imagine that it is very close to the atom. And
Okay.
bond pairs are slightly away from the atom. It's not that they are out of the atom entirely, but they are slightly away from the atom, central atom. Okay?
Yes, sir.
So
Okay.
now, because they are very close to the atom, central atom, they put they repel the bond pairs
Hmm.
because these are negatively charged, these are negatively charged, these are negatively charged, and these are negatively charged. Correct?
Right.
So because of that, what happens? These are putting additional pressure, correct?
Mm.
So instead of having this structure, what happens is we have the structure slightly modified, correct?
Correct.
Okay. So this becomes, and still, if you can, this is your arrow, you will make the arrow the same way, correct?
Hmm.
This and this will cancel because they are, like, if you calculate 0.8, the magnitude is same and the direction is exactly opposite to each other, so they'll still cancel out each other.
Okay.
Okay, and we still have a resultant which is over here. That resultant will be existing. So because there is a resultant, this molecule is a polar molecule.
Okay, sir.
Correct? So how
Yeah.
to remember Vesper now? If there is a lone pair and lone pair, their repulsion is greater than lone pair and bond pair, which is even greater than bond pair and bond pair.
Okay. Yeah.
Can you write
Understood.
down that
Yes, sir.
for Vesper? Ideally, it is taught in grade 12.
Okay.
But many times what happens, because Lewis structure is taught now, you already have the concept of it, so it is easy to build on the concept so that you don't struggle in grade 12.
Right. Okay. Okay, sir. Written down. Okay, sir. Done.
Done. Okay, so that's done. Then okay, now I want you to try uh, CCl4. Now if you make CCl4 your normal way, you will write it this way, correct?
Yes, sir.
Okay, but this is two-dimensional structure, correct?
Yeah.
But in Vesper, we consider three dimensions. So when we say three dimension, that means you have two bonds in one plane, correct?
Okay.
Oh, sorry.
Yeah.
So you will have two bonds in one plane, okay? Then one of them is going behind the screen, okay? And
Okay.
this one is coming out of the screen towards us,
Okay.
okay? So if you consider this structure two-dimensional, the bond angle will be 90 degrees if you
Right.
consider the two dimensional. But if you consider this 3D structure, right, the
Mm-hmm.
bond angle will be 109.5 degrees.
Okay. Got it.
Okay, so that is the importance of Vesper over here, correct?
Okay.
So Vesper
Yeah.
actually tells you the true geometry of the molecule.
Mm-hmm.
Okay,
Okay.
is this taught to you?
Yes, sir.
Okay. Now, can you try the what do you say, whether the molecule is polar or non?
Yeah. Okay. In this one, it's non-polar covalent.
Correct. Okay, now that's correct. Now try CHCl3 and H2O. Draw the structure, share it with me.
Okay, sir. Okay, sir. I'm sending you a photo.
I'm so sorry, I was on mute.
You know this.
Okay, this is what was taught in the school, that first
Yes.
you do it as per the Lewis structure and then draw the Vesper.
Yeah.
Okay, that's fine too. That's okay. Okay, so that's done. Then what else? Molar compound. Okay. Now let us talk about the intermolecular bonding. Okay.
Okay.
So when you have polar compounds, right? So uh, they have two centers that they have a dipole, right? They have a
Mhm.
positive region and they have a negative region, correct?
Right.
So this is one molecule, this is the second molecule, this is the third molecule, and we can also have a fourth molecule over here, which is maybe Cl, H, delta positive, delta negative, right?
Mm-hmm.
And then what happens is the negative center of one attracts the positive center of the other.
Mm-hmm.
Okay? Negative center attracts the positive center.
Right.
Negative center attracts the positive center. Negative center attracts the positive center. Okay, same thing over here. This is done. Okay, same thing over here. Correct?
Yeah.
So basically, what happens because of this partial charges is there is a network that is formed,
Okay.
correct? Which holds the molecule together.
Okay. And this is dipole, I believe?
This is dipole dipole.
Okay.
So there are three types now. One is I generally call it only two types. Dipole dipole is one,
Mm-hmm.
and the other one I call is that is London dispersion.
Okay.
Okay. Now in dipole dipole there is a category or there is a subdivision which is hydrogen bonding.
Okay.
Okay. When will we use hydrogen bonding? When we see that the bond is between nitrogen, hydrogen, oxygen and hydrogen, and hydrogen and fluorine.
Okay.
Okay, it's a dipole dipole moment, but hydrogen bonding why we use because it is more stronger. Why it is a separate category is because if you calculate the difference is maximum delta EF,
Right.
and that means the force is also stronger. So
Okay.
it has been put into a separate category. But if we think technically, dipole dipole and hydrogen bonding are one and the same.
Right. Okay.
Why they are put into a separate category? Because they are stronger than dipole dipole.
Okay.
Okay, and
Understood.
that is because hydrogen is least electronegative compared to that of the other elements which undergo bonding.
Okay.
Okay, so can you write down that?
Yes, sir. Okay. Done.
Okay, so any doubt with dipole dipole?
No, sir.
Okay, now so hydrogen bonding I already explained you it is just dipole dipole moment, but into a separate category because now if you calculate the differences they are maximum. Then
Mm-hmm.
comes the next that is London dispersion. Now, London dispersion generally exists when they are non-polar molecules. Okay.
Okay.
So if you see dry ice, liquid nitrogen, if you see the electronegativity difference over here, 0. That means the electron cloud is equal.
Mm-hmm.
Same thing over here. If we calculate the, like, yes, carbon and oxygen, there is a dipole, but the other carbon and oxygen, the dipole is getting cancelled out. So the
Mm-hmm.
electron is equally distributed. Okay.
Right. Okay.
But what happens because of some reason, if the dipole changes, right? If the electron cloud shifts, maybe because of some motion, because of some impurity or something, it changes. What will happen? That will induce a transient dipole, delta negative, and this should be delta positive.
Okay.
Correct? So, what
Yeah.
is happening over here? There is a transient dipole,
Okay.
and this transient dipole keeps on changing every second. So, maybe now I have made it this way, right? So, the other would be maybe there is a cloud like this, there's a cloud like this, right?
Mm-hmm.
So this is delta positive, delta negative, delta positive, delta negative, okay,
Mm-hmm.
delta positive. So this way the network keeps on forming, okay,
Okay.
right? So what happens because of some changes, whether it is because of some impurity, because of motion, there is an induced dipole,
Okay.
correct? And this dipole is momentary. It is
Okay.
instantaneous. That means it is momentary. Means this is not fixed. It keeps on changing, like the second hand on a clock. It keeps on moving. Correct.
Mm-hmm.
Same way, this structure keeps on changing the shape.
Okay.
Okay. And because of the change in shape, what happens? The dipoles are created, and these dipoles keep the molecules together.
Okay. Got
That
it.
is what is London dispersion.
Okay.
Okay.
Yes, sir. Yeah.
No difficulty with this concept, right?
Sorry.
No difficulty with this concept.
No difficulty. No.
Okay. So that's done then. Let me open the, give me 1 minute. Let me open the textbook. Okay, give me 1 minute. Because there is one beautiful chart that has been given in the textbook. I want to show that to you. Grade 11. Yeah. Okay. Where are we? This. Molecular bonding, right? Yeah, here. I think it is somewhere around 128. 20. Am I sharing the screen with you?
Yes, sir.
Okay. Yeah. No, not this.
Mm-hmm.
Right. Okay. Here, can you see this?
Yes, sir.
Okay. So interacting molecules, if they are polar, right?
Right.
Then are hydrogen atoms bonded to nitrogen, oxygen, and fluorine? If you say yes, correct,
Mm-hmm.
then you will go to, so if you say yes, you will go to hydrogen bonding.
Okay. I'm
correct?
just going to draw this chart as well.
You want to draw it?
Yeah.
Okay, no problem. Go ahead. So it's very effective. Like I love this chart.
Hmm. Okay, sir.
Okay. So then that's all about this unit then. Now you tell me what are the questions you have? Like
Uh,
anything that has been taught in school which is not been covered or something like that.
no, I'm good. Let me just see what we're going to be learning tomorrow and the day after. Second.
Okay, no problem. That's fine too.
Yeah, tomorrow we're doing polarity and physical properties. Let me check what that is. Um, okay, yeah, we just did molecular polarity,
Yeah.
non-polar molecules, polar
So
molecules.
if you look at this chart, okay,
Yeah.
if it is hydrogen bonding, right,
Mm-hmm.
there are strong intermolecular forces. So the
Mm-hmm.
melting point and boiling point will be high.
Okay, so hydrogen bonds are high melting point.
Yes, high melting and boiling point. If it is dipole dipole, then it is intermediate melting and boiling point.
Okay.
Okay. And if it is London dispersion, right, it is weaker intermolecular forces, so relatively low melting and boiling point. And
Okay.
if you notice, there is van der Waals forces, right? So the dipole dipole forces and London forces, because they are weak, they are put into a they were discovered by van der Waals, so they are called as van der Waals forces.
Okay.
Hydrogen bonding is stronger than them, so it is separate.
Okay. Well, it is intermediate. Yeah. Mm, mm,
Okay, and there is one more chart that you know this concept already. I'll just revise the chart with you.
mhm,
So if for all covalent bond, what is the delta En value for each bonds in the molecule, right?
mhm.
So molecular has polar covalent bond. That's fine. Molecule has only non-polar covalent bond. Straight away the molecule is non-polar,
Okay.
correct?
Yeah.
If it is non-polar means London dispersion. Make
Right.
sense?
Okay. Yeah.
Molecule has polar covalent bonds. Now what we do? We check whether the molecule is diatomic or polyatomic. If it is diatomic, straight away the molecule is polar.
Okay. Yeah.
If it is polar, there are only dipole-dipole moment or hydrogen bonding. So if it is HCl, HI, it is dipole-dipole.
Okay.
But if it is HF, then it is hydrogen bonding.
Okay. Yeah.
Clear?
Yes, sir.
Now, if it is more than one bond, polyatomic molecule, right? Then we look into the shape. Is the shape symmetrical? If the answer is yes, then it becomes nonpolar. If it is
Okay.
nonpolar, means London dispersion. But if it is asymmetrical, then the molecule is polar, right?
Right. Okay.
So if it is NH3, H2O, then it is hydrogen bonding because OH NH.
Mm-hmm.
But something other than that would be dipole-dipole,
Okay.
like CCl.
Right. Okay.
So please make this table too for your
Okay.
reference.
Yeah. Okay, sir. Done.
What's done then? Okay, so all the intermolecular forces, everything is covered. Another, this is what I already discussed. Yes,
Yeah.
network, and these concepts are extremely essential. Mm. Okay, and yeah, is solubility also part of it?
I believe so. Yeah.
Okay, then if solubility is part of it, because this concept is again repeated later on in another unit for solubility. Okay, so
Mm-hmm.
for now, just write down this term like dissolves like.
What's the sorry?
Like dissolves like.
Okay. Like
Okay,
sounds like.
so if it is polar, it will dissolve in polar solvent. If it is non-polar, it will dissolve in non-polar solvent.
Okay.
And ionics are generally polar,
Okay.
so they will dissolve in polar solvent. How and what happens? We will discuss that in the next class.
Yes, sir.
Okay.
Okay.
Apart from next in the sense when the unit is there for solubility. Uh, then, okay, tell me what is the next part for you from your syllabus?
Next after that, on Monday we are doing intermolecular forces. We just did that.
Yeah.
Review day and then test on Wednesday.
Okay. Then what about reactions and all?
I think that's the next unit. So
Reactions you have?
Next unit. I don't see it on the calendar here.
Okay, no problem. Then I think we should start that.
Yeah, this is what we are doing, like on the test.
Yeah, so interpreting of all the periodic table, that is group period, metal, non-metal, is calculating atomic masses, atomic theory, and trends. Okay, Lewis structures, covalent molecule, ionic process, covalent bond. Okay, do you have any questions that your teacher has given you which you want to solve with me now? If we are not starting the new unit.
No. Did we go over properties of ionic and covalent compounds?
Yes, we did.
Okay. All right.
Just check your notes.
Check.
If Yeah, check your notes whether
Ionic super strong fixed position. I don't see it, sir.
you don't see it. Okay, no problem.
No, sir.
Mm, chemical bonding, electronegativity. Okay, here I go. I'll share my screen with you. Give me 1 minute.
Yeah.
Okay, check this table. Okay, physical properties of ionic and molecular compound. So ionic compound, crystalline solids. Molecular compounds could be solid, liquid, or gas.
Okay.
Okay, physical properties, hard and brittle.
Okay. 1 second. I'm going to
Okay,
write these down. Okay, sir. Done.
any difficulty in understanding,
No, sir. I understand.
right? It's easy.
Yes, sir.
Okay, now there is okay. Let us do this question then. No, not this, not this. is about the Lewis structure. There is one question on this unit which, give me one minute, let me search. Okay, can you do this?
Yes, sir. Okay. For the boiling point and melting point, how am I supposed to get that?
Okay, so just mention high or low here.
Okay,
Okay, because here you just need to understand whether it is ionic or covalent.
right, okay,
Okay, based on these, the information available, you will just mention, and you know if melting point is high, boiling point will be high.
right, okay.
Correct? But it
Yeah,
is decomposing. So decomposing means the compound doesn't exist to become liquid.
right, okay,
Okay, just mention high.
okay,
And if you don't know anything, just say Na.
okay.
Hello?
Yeah,
Are you able to solve it or no?
yeah, I'm right. I'll send you now. Okay, sorry.
Okay, no problem. So your first test that you did was on nomenclature?
Yes, sir, nomenclature and periodic trends.
Okay, periodic trends was also done. That's good.
Yeah, we just did it this week. We haven't gotten
Okay.
it back yet.
Okay. And what
Yeah.
about the previous test?
Previous tests, still haven't gotten it. The previous test I got a 27 out of 28.
Okay. What was that on?
That was on just nomenclature.
Okay, just nomenclature. Okay.
Yeah. Carelessly low. Okay, sir. I'm sending to you in chat.
Okay, sure. In chat or on WhatsApp?
Oh, in chat. I did it on the thing.
Chat, okay.
I wasn't sure for the first one because it's saying it doesn't conduct electricity in water, but the melting point is high.
Okay, yeah. So if it is not conducting electricity and the melting point is high, then it is covalent.
Okay.
Okay, do you know diamond?
Yeah.
Diamond is made up of carbon and it is the strongest substance that is known.
Right.
Correct? So that is a covalent one. So the hint from there is that it is uh, like it doesn't dissolve in water and it doesn't conduct electricity and melting point is high. If these three combination, then it comes under molecular solids.
Okay.
Okay, and these molecular solids are covalent in nature.
Okay. Got it.
Okay, ionic, ionic. Uh, so what is M? M, what you have written
So
M?
I meant covalent. I wrote down molecular
Okay,
from the table.
okay, okay, no problem. So low, that's fine. Melting point, all right. M, okay. Between low and then dollar, okay, that's fine. White crystals, yes, yes. 801, right. Okay, now there is also one more property that they might give, right? White crystals, here it is mentioned, dissolves in water, conduct electricity, right? They might
Mhm.
say that it is brittle,
Okay.
okay? So if it is brittle and high melting point, soluble in water, definitely it is ionic. So yeah, you have picked it correct. Now here it
Okay.
is white crystals, uh, dissolves in water, conduct electricity. No, you have selected the right one, that it is molecular. Colorless gas, doesn't dissolve in water, doesn't conduct electricity, low, molecular. That's correct.
Okay,
Okay.
sir.
So except for the first A, rest of the things were correct. So expect these type of questions on your test.
Okay, sir. Got it.
Yeah. Let me mm, let me see if I can find any other question
Yeah.
on that topic. But you have understood everything that has been done so far, right?
Yes, sir.
The table I was there. I remember there was one question somewhere. I believe it's not there.
Okay, sir.
I'm not able to find it. No, sorry. I'm not able to find it. Maybe it is part of some other book. Okay, should we do something else or should we call it a day?
Let me see if I have any questions, sir.
Yeah, you can share it on WhatsApp or on chat. Either way, it's fine.
Yeah, okay. I'm just looking through my notes, seeing if there are any questions. Mm, Sir, I think we're good. No question.
Okay, then let's meet next week.
Yes, sir. All
Okay.
right.
Bye.
Right. Bye, sir. Thank you.